In this video, we're going to create an NFT from scratch using the Open Zeppelin libraries for Soroban smart contracts and then deploy it live to the Stellar testnet. If we jump into the Open Zeppelin Stellar contracts repository on GitHub, we can go into examples and then non-NFT sequential minting. Zoom in a little bit and have a look at this contract. You can see we're importing Stellar non-fungible token. Then we have to set a URL for the metadata, a name for the token, and a token ticker symbol. All should be fairly simple. One slight complexity is that this token currently can mint as many as you want. I want to put a cap on it. So we're going to alter the contract ever so slightly to do that. So if we have a look at the library itself, we can go and find this sequential mint function. And we can see this is returning a U32, an unsigned integer 32-bit token ID. And then this mint function is actually returning a token ID as well, which I guess that's going to be U32. So let's change this type to token ID. And then we're going to return the token ID here. Then what I'm going to do as well is add an if statement so that if the token ID is over a certain amount, I want this to panic and revert back to the original state, limiting the amount of tokens it can be in existence. So if token ID is greater than 100, panic, maximum minted already, fine. And then if not, return a token ID. To compile and deploy this code, I'm going to be using Rust and the Stellar client. You can get Rust from rust-lang.org, and then you can use the cargo, which is the package manager for Rust, to install the Stellar CLI. Zoom in a little bit. So first thing we'll do is run cargo test. This is just to compile the contract and make sure everything is building okay. I haven't got any unit tests in place yet, but obviously if you're doing this in production, you want to write your own unit tests as well. While that's building, we can go into any AI image generator and let's create a pixel art image of a kitten, make it cute in 80s computer style for an NFT project. That's awesome. Let's choose this one. I'm going to copy that image and I'm going to open up Inkscape. So I want to kind of work with this a little bit using vectors. So let's open up a new file, paste that in, and then I'm going to trace the bitmap. So I'd like a little bit simplified into a vector. Not so much that it's ugly. Smooth it. Optimize it, and then apply. And there we go. We've got a kind of a vectorized image. The original's here, and this one's here. Going to need some background on that. Let's put this in here. Then we're going to create a similar image around the back. Just a little placeholder. Copy these two and center them. And move that one to the back. And we've got a cute little posterized cat. We're getting a little bit out of the scope of this tutorial, so that will do fine. Highlight the selection, export it at 1080. So now I'm going to save this as an SVG file. Go to Save As. Create a new directory within my project. I'll call this artwork. The next job is I want to upload this to a decentralized file system. I'm going to be using IPFS for this, the interplanetary file system. You need an uploader. There's a free one called Pinata. This is available at app.pinata.cloud. And all we do is simply set up an account, go to add, file upload. Find that file we just worked with. Public. Version 1, that's all fine. Success, file uploaded. So we've got this IPFS address now. Let's find an IPFS gateway. Post our image in, and you can see this is now hosted on a decentralized file system. Now, rather than link directly to this, I'll actually create some JSON metadata, which I'm going to link to from the smart contract. I have a previous project that's done something similar, so I can go into this here. This one was not using the OpenZeppelin libraries. It was done quite a while ago. So let's put this in public, change the metadata. And I want to update this. So name, I'm going to call this Soro Kittens. Description, kittens on Stellar Soroban. I need my issuer ID. This is going to be the address that deploys the contract. So let's go into here. I can use Stellar Keys for this. And I want the address of one of my accounts. So I'm going to go Stellar Keys, address James. That'll give me this public key. I'll copy that into here. Code, I'm just going to go SKT. And then with that metadata, I'm also going to copy the name and the ticker symbol into here. So Soro Kittens, SKT. And then I need the IPFS address of the file. That's this one. Now I'm going to upload this metadata as well. So if we go back to Pinata, add, upload file, metadata.json, public, upload. And we've got another IPFS hash here. So I can go into the library, where it's here, I can go IPFS and paste that in. I'm going to save the contract now, and then I'm going to go back to the Stellar client, clear this, and build the contract for WebAssembly. Now it's finished building, we can go ahead and deploy it using Stellar contract deploy --wasm target to that wasm file that we just built, using the source account as James and the network as testnet. Let's hit enter. We'll simulate the transaction, submit the transaction, sign the transaction, and what we'll end up with is a contract address for that contract. We've deployed that NFT to the Soroban network on Stellar. And there you go, CBXT. If we copy that contract address, we can go to Stellar Expert, switch it to testnet, paste it in, hit enter, and you can see our contracts here. We've got the interface with all the different functions you'd expect within an NFT contract. I hope you've enjoyed this video on using OpenZeppelin's libraries to build out NFT contracts on Soroban. There's more information on the tutorial linked in the description, and thank you for watching.